Hi, my name is Dennis. Welcome to Foundations AWS Identity Access Management and Permissions. Today we're going to learn about identifying AAA services. Now, AAA not as in the towing service, but AAA in the fact that we have authentication, authorization, and accountability. These services together are inside Amazon Web Services, and we can see the use cases for each one as we go through IAM or Identity Access Management. We'll be able to analyze and create IAM roles and policies using JavaScript object notation format. Don't worry if this sounds boring to you, we're going to learn. We're also going to learn about the best practices using single sign-on options with short-lived credentials from the command line, and we'll see that in the demonstration, and how you can set it up in your lab as an optional feat. So, IAM fundamentals means we'll learn about everything that requires AAA services to your Amazon Web Service workloads. We want to make sure we have authentication, authorization, and ultimately accountability to make sure we know who, what, when, where. Not necessarily the why, but sometimes why, depending on the context. So, what is AWS IAM to begin with? Well, it's your thing for everything authentication, users, tokens. We have an idea that everything that is a source is a principal. So a principal could be an account, a user, a role, a federated user using single sign-on, another application. It makes a request using API calls, and ultimately it gets authenticated through IAM, and it gets to an authorization standpoint. The authorization standpoint says, what can you do? Right? What do you authorize that you can and cannot do? We have this in the form of JavaScript object notation policies. The policies help act as a gateway, and those elements of a policy include effect, action, and many others. Ultimately, if your policy allows or fails, if it fails, it stops right there, and you don't have authorization, you get an error message. If authorized, you have access to do different things on the resources accordingly based on those policies. So IAM ultimately is your gatekeeper, your first line of defense for all things authentication, which is up here, who you say you are, authorization, what can you do, and ultimately accountability. It'll help you determine the logs, who were allowed, who were denied. And we can see those in CloudTrail events, which we'll showcase in the demonstration later today. Ultimately, you want to have granular access control capabilities. Right? Granular access means, well, we don't want to just say, hey, everyone can be an admin or everyone needs to be a power user. We can actually say, you only need access to do this one thing against this one service, such as if you have a network operations control center, you have analysts that only need to read access to the health of the environment. They cannot make changes to them. That's where DevOps comes in. They can make changes to the environment if necessary. They have different permissions from NOC analysts. NOC analysts should be read-only in most cases. DevOps should not need any network visibility requirements. They shouldn't have to have all types of other reporting capabilities and matrices and certain services. So DevOps will have completely different permissions, granular permissions, and ultimately multiple methods of access. We talked about a little bit about that in a different model where we have access being SDK possibilities. We have CLI. I can type, if I can actually write it out, CLI and the console are three main sources. Now, everything programmatically is usually by a script, which is CLI. Everything programmatically by a native program that's supported, such as .NET, Python, Node.js, whatever your pick may be, it's supported by IAM to help you authenticate to itself. Okay, authentication means who you say you are, such as an ID badge, or possibilities of other items, and we can also have authorization, which is what can you really do with that badge once you get in, and ultimately accountability. Can you trace what I'm doing in that building with that badge? So, one of the smallest but most important features of IAM is that you have the ID of a user. Now, I know what you're thinking. Well, doesn't everything have a user, Dennis? Yes, of course, there's always that need for a user, but you don't necessarily have to have users in IAM to still get authentication. What does that really mean? When an IAM user inside Amazon Web Services accounts means that you're creating a user with a username and a password, they can assume what's called a role, which is, hey, I'm an admin one day, or maybe I'm a NOC analyst another day, temporary, right? The whole idea of a role is temporary credentials. Now, IAM users have a very specific attribute is that they always have a password and they can have multi-factor authentication, such as a soft token. If you use Microsoft Azure, Google Authenticator, RSA token on your phone, and you have those little numbers that expire after 30 seconds or so, that's MFA, multi-factor authentication. An IAM user is an entity that you create inside AWS and represents a person or services that you need to interact with other AWS services, primarily through mostly through long-term credentials until you assume a role. Now, you don't necessarily have to have the user inside it. So I might call myself DW Chow, which you'll see in our demo, and that's the user, and I have a username and a password. However, I don't have to be inside IAM. I can actually be inside my on-premise corporate environment like Active Directory, and I can be authenticated directly inside DW Chow here. And because a corporate Active Directory, it's called an identity partner. It has a trust with my AWS account and replicates the needs and says, hey, I authenticated Dennis. He is who he says he is. I just need authorization to pull back and do stuff with the AWS account. We do this with SSO, single sign-on, also known as federation. So IDP being identity providers, and identity providers are usually trusted delegation partners with the AWS account in the question. Again, Active Directory, if you're using Oracle or some other IDM, identity management solution on premise, you can usually interact with that over what's called SAML, right? Security Assertion 2.0 is their supported protocol. You'll learn more about that as you get into security concepts or other authentication pieces, should you become an IDM specialist in the near future. Now we have the other option we call groups. Groups are a non-nested means of saying I can have multiple users in multiple groups, but I cannot have multiple groups inside each other. Notice that they have a fairly flat hierarchy, where we have multiple groups and multiple users in those groups, but you cannot have multiple groups within each other, okay? The other thing to note is that as a principle, as a source entity, groups cannot be applied to what's called a resource policy. Now, a resource policy is something that applies directly to the resource. Now, S3 might have its own policy saying, I want people at the group admins to be read-write. So anything Bob and Susan have access to. I cannot say group admins being the source. It just won't happen. I have to explicitly say I want the S3 resource policy saying, hey, access me through the account, or specifically Bob and or Susan in my logic. I cannot specify the groups in that case. But the other great thing is you can still attach policies. So that could be a different set of permissions, right? Authorization. I can be admins for sure. That means I need all, and then maybe I need some for testing purposes, right? I can have policies attached to these groups and then inherit it from all these as the users that are part of these groups. So that's a great way to administrate things. It's just a collection of users that have the same policy permissions, right? The same authorizations. Now, the whole idea of roles. When I assume a role, when I said I was going to say, I need to be Bob or Bob's system administrator for an hour, but I want to return back to my regular IAM user whenever I'm done. Let's say I'm a full admin. You always want to use the least privilege possible. So when you put on the hat, you assume a role, you have a very specific set of policies to resources for authorization. And the first thing you do with a role to even assume it is you call STS, which means security token service inside AWS. It works in tandem with IAM. So STS is not IAM, but it works with IAM. Now, working with IAM means that IAM authenticates me, the policies authorize me, and STS gives me the token to go and actually have the temporary credentials, right? The temporary authorized credential to say, hey, I'm going to connect to this other service. Here's my token. Here's my free pass for a limited amount of time. So when I need to assume a role, I make an API call through my application or the console, which is all an API application. It's just nicely wrapped for you as a GUI. It kills IAM to authenticate, and ultimately, if you get authenticated with a success, IAM and STS will provide you a temporary token, and then you present that token to the service that you're running, such as VPCs, EC2 instances. So ultimately, you can assume a very specific role that only deals with a database and EC2 instances, maybe not anything with S3. If you try to use the role with S3 and you're not permitted by policy, authorization in this case, you'll get a deny statement, which is really cool. So you can actually have very granular authorizations after the authentication to determine what your needs are with least privilege. So always assume a role whenever possible as a best practice. Now, when you use federation, when we have Active Directory, for instance, you're assuming a role within the account. So even though you may authenticate to AD, saying I have a username and password for Dennis, and I have the correct password, it's still going to reach out to the IAM and STS API service exposed to the internet, or and have a specific trust between AD and your account. Right? There's a trust link. There's a two-way trust, and it's basically saying, "Hey, I trust that the Active Directory service is doing the authentication piece. I'm just providing the authorization and a temporary set of tokens that my user from on-premise can use with these services specifically." That's all it really means. So a role is just a temporary set of credentials, not long-lived, and is commonly used in SSO, federation, or other best practice techniques. Remember, STS, role, short-lived. So why would you use a user versus a role? Well, here are some use cases to think about. If you create an AWS account just for yourself and you're the only one in it, maybe use a user. That's perfectly fine. Or you have other people in your group that need to work on an account and you don't have any other identity management system. You have usernames and passwords for each one. You have some form of authentication, authorization, and accountability, and it has to be long-term. Or if you want to use the CLI and you cannot refresh or re-authenticate interactively. So if you have an Internet of Things device and you don't have any other mechanism to automatically refresh its tokens, but you should, and you perhaps need to require MFA, multi-factor authentication, and a human cannot provide that extra token, maybe you need to use an IAM user instead. Again, IAM users mean long-term credentials, though, could be dangerous, not exactly best practice if you don't require it. IAM role cases are when you create actually workloads, apply least privileges to workloads. You want to create the application that is for mobile phones or make requests directly to AWS services rather than your workload or authenticate to your account. So when you're thinking about use cases for IAM users, you think of account. When you think of roles, think of workloads or services. Right? And of course, you have federation requirements. So short-lived credentials are always best case. And so what we'll see later on is that as you generate these long-term credentials, if they get compromised, you have to manually change them. Whereas a role, because it's already temporary and it cannot be reused or replayed, you have a finite amount as an attacker. You have a finite amount of time to actually do something with those credentials, and then poof, it's gone. Users have to re-authenticate and get those original tokens back, or a new set of tokens back from STS. Now let's look at authorization, trust, and policies. Now when we trust money, I trust you. You might trust Dennis to say, hey, this class is great. We want to make sure that I'm giving you the proper ability to say, tell me and give me feedback and pull something from me. Right? That's what trust means. From a policy standpoint, you may pull something back from me, but I could say, hey, I trust that you can pull something from me, but I didn't say what. And if you didn't have a policy with me that says what you can pull from me in terms of information and asking me questions, I might just deny it implicitly, or I can explicitly allow you to say, I'm only going to give you only certain information in this conversation. Trust allows that access to something, right? You want to trust that the principal service, EC2, anything with the EC2 service principal, can assume a specific role, right? Can put on the role hat. So an EC2 instance can actually say, hey, I need to authenticate to IAM. And I need to get temporary credentials myself automatically. And I want to be able to assume the role. The role can be doing stuff within S3. And in this case, read only, right? I want to say any S3 buckets in this account or some other account, I want to be able to read a list of buckets in that account, and I only want EC2 to be able to assume that role that allows that read bucket access. Okay, authorization. That's an important thing to keep in mind that we have several elements going in play here. We have the effect, which is right here, which is allow or deny in most cases. Remember, there's an implicit deny, but allow is the best practice to put up right after deny if you need to have an explicit deny statement. You also have action. So the action is the APIs that are there for you specific to the service using a prefix. You can also use wildcards, say get everything or anything related to lists. Or you can be very granular and say only these APIs are allowed. You also have the resource, right? EAR, right? Ultimately resource. All resources in your account or just a very specific bucket, for instance. And then finally, P for principal. Where do you want principal for your trust, right? And even though these are both JSON, a trust is different from a policy. They're both policies, but you have a general policy for access to and or deny something. The trust policy is also allowing or denying trust to even assume a specific role, right? There's a limit of 6,144 characters, and the syntax in both of these cases is JavaScript object notation. So when you see these curly brackets, closing and ending, which look very similar to perhaps Python key value pairing, those are Python dictionaries, for instance. Those are forms of JavaScript object notation. Now, another type of policy is identity policies. So if you wanted to prevent access to your account at certain dates and certain time ranges, you can create a condition, and you only want the allow to happen at certain times. You can also provide IAM with entities attached for other conditionals, like from an IP address as a conditional. You can have 10 managed policies per user, per role, or per group. So it's just really cool. You can have lots of layers of what's happening, and it'll always be the lesser of the. So if you have overlapping policies, for instance, with different permission sets, it will take the least privilege of the up to 10. There's implicit denies unless explicitly allowed. Right? It's kind of like a security group in that regard, that policies already have denies by default. That's how the logic goes. You can attach them inline. So inline means that if you attach a policy inline to an entity, if you delete that entity, the policy goes away with it. Ephemeral. It's just like a source port for a TCP connection. If you have a managed policy, it just means that policy is permanently put into your IAM, and you can reference it over and over again and attach it to things despite deleting the original group or object. Your policy is attached and not inline, so therefore not ephemeral. Resource policies are a little bit different. So if you have S3, for instance, which is your storage bucket, or you have EC2, and you want policies that are applied directly to the service for that particular object, that is a resource policy. And you can also have other granular requirements. Notice that you have access resource addition, and then you have a principal. Who can access your stuff? Okay. Now the interesting part is, not only can these are related to the very specific service details, regardless of who comes in, you can actually specify that you have more than one principal that can access your resources. For instance, I only want these accounts right here, these two accounts to access my S3 bucket and be able to put objects in it and put object ACLs and lock down those objects from those two accounts. The interesting thing is what we saw previously, if you go back, we had identity policies. Identity policies directly to a user, group, or a role, but these take priority over identity policies. Resource policies take priority over identity policies, okay? And the reason why that happens is because you're trying to access me. If I'm the S3 resource, I want me to be the access gatekeeper of me first, rather than you saying, or a third party telling me, hey, Bob is coming to see me, or see me as Dennis, and I have a policy fixation on that, versus me controlling myself that access to Bob having that interaction. Sorry if there's anyone named Bob. I just had to use that as an example. Let's move onward. So resource policies also have some of these services also have the capability of resource ACLs. These are considered legacy mechanisms, okay? And they've been replaced by resource-based policies. So if you think of resource-based policies, think of them as more uh, the non-deprecated version of an ACL. Now, ACL means access control list. If you want to look at the difference between an identity-based policy, it's that John, Carlos, and Mary and Zane can do specific things. A resource-based policy or resource-based ACL is the complete complement to that, right? You're saying, hey, resource somebody, right? S3. Someone can specifically for me read information for me, put object in data inside me as an S3 bucket, for instance, versus me saying, oh, I'm allowing someone very specific access to one more resources. I'm only allowing people to me versus the opposite way around. That's how you should think about it. Now, resource ACLs are deprecated and are typically not used, but they apply at the object layer, and so you can actually apply both of these concepts of identity policies and resource policies / ACLs at the same time. Think of it as layers of security, just like you would with security groups or versus a network ACL. And there's also the concept of boundaries and service control policies. Now, boundaries basically saying what's the maximum you can do with a service using a policy, or a service control policy is what you are not allowed to do specifically. So they don't grant any permissions. They only say what your limit is for using XYZ service. And we'll see this in the demonstration about how this relates to AWS organizations, which help you enable SCP. So when you think of organization, think of SCP boundary. Right? Boundary doesn't grant any permissions explicitly like an identity policy, but here's the thing that you have the flexibility of maximum permissions or denied specifically for SCPs, which is the best practice, and boundaries at the service layer when you're creating an IAM policy for identity policies are the max allowed permissions possible. Okay, so those are what we call guardrails inside Amazon Web Services. And guardrails allow you to say, hey, if I screwed something up or if there's a misconfiguration somewhere at the system administrator level, I have a higher tier level of enforcing specific policies to say I can do this up to a certain point, or even if I allow access to EC2, if I have a higher level SCP policy at the organization master parent level or the parent level account controlling me, it can always say no access to EC2 whatsoever. So even if I have an IAM policy to a user that's an admin and allow EC2 access, it's not going to do it. It takes priority over your identity boundaries and access control based policies. Now, there's another concept called session policies. Now, session policies are a little bit different. This looks strikingly similar to a trust. Okay, strikingly similar to a trust, and that's because it really is. So, a trust is considered a session-based policy because you're using STS. Whenever you think of session and trust, think of STS, right? Secure token service, and it's applied at the role level. Remember, roles STS are short-term lived credentials. Now, it's interesting to note that I'm not allowing a root user, I'm allowing the root account. So everything under the sun of 111122223333 is allowed to assume the role of some fictitious role that I presume here. So you have what session policies can be trusts, and you can specify how long the STS token will last. By default, it's 1 hour. You can have it up to 12. And your effective permissions, consider them as logical ands. Between the resource policy, identity policy, and the session policy, if I have granted access on all of these for a very particular resource, I have access. So my effective permissions is the overlap across all three of these. If any one of them is missing, if I can't, session policy again, assume the role and get an STS token, I can't access anything at the resource anyways. Just the same as if I can assume a role, but I don't have the ability to have an explicit deny, or I don't have an explicit deny, or I don't have a explicit allow, right? I'm not going to be able to access XYZ service. Now, even if I had those two going for me, if the resource-based policy says, hey, I don't want Dennis anywhere near me, get him the hell away from me. Get him away from me, the S3 bucket. I can deny Dennis or Dennis's account specifically, and that falls to the ground too. So you actually have multiple layers of security using effective permission policies if you use all three of these main types. Very cool concepts. Now, our policy evaluation route. Now, I did say that there was denies, explicitly or implicit denies. Let's start with the deny decision at the very top here. Do you have a deny statement? Oh, you do? Sucks to be you, man. You are denied. You don't have to go any further. Right? It's actually the best from a performance standpoint, computationally. So the best practice, deny statements at the top. Make sure that you deny explicitly what you want denied. If there's no deny based on the matching evaluation and US principle, is there an organization SCP that is allowing you to do something? And if so, continue forward. If there's no explicit allowance, then there's an implicit deny. And you also don't move forward. Now, next, based on the priority, is resource-based policies. If you're an S3 bucket and you don't want Dennis anywhere near that S3 bucket, well, there is no explicit allow. I don't have a trust, right? And even though I don't have a need for anyone to access me, I'm just me by myself, or I want another AWS account that isn't related to Dennis, I'll allow that person, and Dennis can't do so. So if there's an allow, then your final decision is allow at the resource-based policy, right? If you have one, you can still have you can still have denies if you need to. Now, if there's no resource-based policy attached at all, it's going to go into the IAM permission boundaries, right? What's my maximum capability of the principal? So if my maximum capability of the principal includes, me using EC2 in a certain way, right? And if there's an allow for that, then yes, keep going. If not, right, if there's no explicit allow, then the final decision is again denied because implicit deny. Next, we go to the session policy. Okay, I have resource, I have IAM. Am I allowed to even assume the role to actually access EC2 resources or S3 resources? Is it an explicit allow? Yes, go to the identity-based policy and see if Dennis actually has permission from the systems administrator, or no, final decision deny. And of course, we finally go to identity-based policies, which is lastly evaluated. Last evaluation. Identity-based policies are always last evaluated because why? The hierarchy that makes the most sense is all the way up here to the left, right? If you said I am Dennis, I am authorized to do whatever I want. Let's say I'm authorized to go into an FBI building in the US. I've authenticated that yes, I'm Dennis and who I say I am. That doesn't give me authorization, right? There is no policy to allow Dennis, and you wouldn't want me on my behalf or my boss on my behalf saying that it doesn't allow a policy to enter an FBI building whenever I want. No, that would be an organizational level policy of the FBI to allow me in. And even if I get into the building, if I need to visit a very specific person, I need a resource policy. Then I have to understand that should I go to zones and areas that I shouldn't be? Does my badge access terminate at the end of the day? Well, all these have to be considered, and so those have to be considered first. So anything closest to the resource that your destination is evaluated first before after the organization level. Anything related to the person that's been assigned by their system admin or to themselves attached, you trust those the least, right? And trust those in order from left to right. So please keep that in mind as we go through and look at our policies. Let's take a quick break, and then we'll be back. Okay, welcome back from your break. Let's get back started to IAM integrated services. What can you do with it besides create a user or some roles and be AWS native integrated only? Well, we talked about a little of the concepts like SSO and federation, but there are many other concepts that go with it. Right, SSO and federation at the simplest level just means you can take on-premise stuff, like Active Directory, my corporate network. I authenticate, and you trust me to authenticate that, and the Amazon Web Service single sign-on service will go ahead and grant you those tokens and let you assume those roles to access AWS specific services in one or more accounts. The AWS SSO can also use identity providers, like external ones like Google or something like that, to act as your SAML assertion other than your Active Directory on-premise. It could be another provider, Okta, for instance, perhaps another ServiceNow, and many other possible services can be your identity provider. It does not need to be Microsoft. You can also use AWS SSO to have corporate web page portals. So if you want to always access Amazon, not just utilize AWS SSO to also authenticate to Office 365, Dropbox, Slack for your productivity needs are also elsewhere in the cloud. AWS SSO, once you authenticate to AWS SSO either through on-premise or directly with it using a SSO user directory, which we'll cover in a demo, as long as a directory is authenticated, you can access other things and other applications that have SAML assertion capability. So that's what we mean by federation. You're trusting something and you're providing them tokens and authorizations based on the trust of an outside system. Now, also that goes with that hand in hand as a great complement is AWS organizations. Now, AWS organizations simply means that you can organize one or more accounts into a nested series. So unlike IAM users and groups, you can actually nest organizational units and different accounts together based on their need, and you can provide guardrails, those boundaries based on SCPs, service control boundaries. Say, hey, if you're a nested OU for HR and you have your own cloud app services, but you're a dev here, why does HR need write access to database, a database related to programming? Or why do they need programming access to begin with? Maybe they write stuff to a HR application database, but they shouldn't have to launch EC2 instances. You can create SCPs that prevent them from doing so. Unlike a dev, they need multiple access, but maybe they don't need access to billing information or cost analysis. So ultimately, AWS organizations can also act as not a way to just organize, but also provide security control guardrails and boundaries. Additionally, the advantage of AWS organizations is that if you have a large enterprise using multiple accounts, if you use an organization, you get the benefit of discounted billing based on your scalable needs in a central location, and you can have a management account such as your security and financial team to get that information and get the most out of your dollar with AWS services based on these multiple account tiers. Now, a third service is called Cognito. You have the idea of user pools, which are user directories for your apps. So if you create a mobile application, for instance, you can have a user pool which acts as you signing in and registering as to use the app to begin with, such as Google authentication, Amazon authentication, Facebook, whatever it may be, or anything else that has a SAML or other possible customer identities. You can have an external IDP allow your user to sign up for your application. That is a user pool requirement. For identity pools, you can actually utilize it for an SSO requirement. An identity pool will actually grant users access to AWS backend services, not to your app, but backend AWS services. Also role-based, so you can actually utilize app or desktop, use an identity pool to exchange tokens to AWS services. Now you might think, why would I do that versus SSO? Well, you may not have a corporate environment, right? You can utilize user pools and identity pools together, or you can use a different IDP, either through SSO or not, to utilize other AWS services directly. The whole idea is the best use cases really is Cognito for authentication, authorization, and user management for web and mobile apps when you don't have something connected to a federal, not federal, but a federated corporate environment that has a trusted IDP. You want to use SSO for federation and things of that nature. If you're looking for mobile application needs and you need to sign up a user for the application level itself, user pools are the way to go. And of course, identity pools are ways to grant mobile users the ability to access raw AWS services on the back end using any form of identity provider. That's the main difference. So now it's time for a quick break, and then we'll get back and do our demonstrations and show more of the IAM policies, roles, and practices put to use. Hi, and welcome back. I hope you had a great break. Let's get started on understanding more about IAM and how it plays with your account. I have an account here, and I'm going to go to IAM right here. You can go up into the search bar and type in IAM. One of the main things when you sign on to your account, just keep in mind that IAM will allow you to use your account ID number that you got in your email, but you can also create an alias to that, and that alias will give you a unique URL that you can sign in, just as an easier way to do so. So that's just a quick tip. Now I created a user, and this user is I'm a DW Chow. And bad Dennis, I didn't create a new access key or rotate it within 130 days, but I did have my last login today, which I'm logged in up here. If ever in doubt, you can find your account number information here, your IAM user information here, as well as your alias right there. Now, I have multiple permissions for it. So I have attached policies directly and inline. So if I ever delete this is an inline policy, and it's an AWS managed policy, not a customer one. So basically, this gets updated and I can access billing information. So it's an inline policy, so I can monitor my own billing needs as I go on. That gives me explicit permission to the policy to me, but not to the rest of my group. So if I had multiple users in these system admin groups in here, only I would have access to the policies for billing. I mean, I look at system admins groups. If I have multiple people, I am admin privileges. So I actually have two policies related to me. One policy that's attached directly as an inline policy, one as a managed policy based on job function, which I'm a full admin of. Of course, this policy will have a bunch of stars in it because I have access to everything. As we see here, effect, action, and resource. And you go to policy summary, and it'll tell me the same thing in a nice little tabular format. Now, if I go to roles, that's a little bit different. Now, the role itself, it's similar to how you create an entity, but it's really about assuming something temporarily. Let's take a look at a very particular role here. We'll use cross-account role. And this cross-account role, or this Lambda, is really for executing Lambda role, and that says it based on its name. But my trusted entity is saying that only Lambda should assume this role, right? So that's a session-based policy. So unlike IAM, where I have a user identity policy attached, right? Here are my permissions inline, my groups that have inherited attached permissions of identity-based policies. I have roles that are are based on services that can assume the role, and I say that trust is a session-based policy. So let's go back to that Lambda execution role, and we're saying, okay, a policy that says execute a Lambda function, cool, and write to CloudWatch logs. So basically, write logs to something, and I have another attached policy to this role saying I want to allow a second account, right? I want to allow myself, this role, whoever assumes this role, a policy permission to assume a role in another account. In this case, I have a secondary account that has a role related to S3 read-only permission requirements. Okay, so you can actually nest them and do cross-account access like that too. More importantly, I have a trusted relationship. So I'm basically saying trusted entities, only Lambdas can assume this role. It can't be a human. It can't be Dennis. Only a Lambda function. Okay, that's another service provider. And it looks like this, where we're honestly saying, hey, a principal is service. I want it to assume this role from SDS. Give them a token only if their AWS based service is Lambda, not a Dennis. But if I wanted Dennis to be able to assume a role, what would I do? Well, I have a EC2 read-only role that I can assume in my same account. And that way I can say, hey, I want to say EC2 read-only. And I only have access to read-only EC2 information inside the console or any other service. A trust relationship says only Dennis Chow, DW Chow, in this account can access and assume this role. Okay, so if I assume this role now, which is you switch roles and you add in your information accordingly, your account number, your role name, you can set a color and display name. I'm going to cancel out. You can do that if you follow along. But watch this. If I switch to the EC2 read-only role, I should see a bunch of errors come up saying I don't have permissions to do anything else. I don't have permissions to look at users. Oh no. Why? Because I only have permissions to do stuff inside EC2. That is the beauty behind the role. Now the role allows me to re-authenticate every 1 hour. And so now I see um, stuff running or not running inside without error. I'm going to switch back to my DW Chow role or my DW Chow user and get out of that role accordingly. Notice that a role is short-term lived. How do I know what the term life is from STS that'll write that token for me? Well, we look at the trust session policy again. So by default, it's 1 hour, but you can change it again to a maximum of 12 hours. Cancel out. And let's go to perhaps the identity providers. I don't have any here, except for SSO, which I created. Right? And SSO is a separate service from IAM, which allows me to federate different things. So in that case, it will assume a very specific set of roles when I do some sort of federation. Now, if I go to AWS SSO, which requires AWS organizations to function, so if you follow along and create it based on the options in your lab, you create a user portal to always authenticate to your account. So I'm going to say Dennis Chow should be able to create access to one or more accounts, particularly this account only, with an admin access set policy. Notice that I have policies still, which are called permission sets. The organization, I have multiple accounts, but I only want him to access this account. So this account has Dennis DW Chow SSO, and we're going to pretend I have this inside Active Directory, but you can always use SSO to have authentication to another identity provider, which you can add here. All right, so this is actually a trust with IAM already. And so it's almost like you're having your own identity management solution. Now, why is this important? Why would I go through all the trouble with this? Well, let's go back to my identity policies and my user itself. I want short-term lived credentials because if I get compromised for whatever reason, I want to be able to revoke those credentials automatically. Well, let's say I'm not awake to do that. Maybe I get compromised for whatever reason by malware late in the day. So if I create an access key, I'm creating a new one tonight, but I'm also going to delete it. So don't worry about accessing my account. This is my secret access key, and this is the only time you can download and see the key. And then you would enter this into the AWS configuration CLI module after you have that installed. So I'm going to go ahead. I created that today. I'm going to go ahead and delete that, deactivate, and I'm going to put it in here to delete. Oh no, you can't get to me. Nice try though. Delete, and now you shouldn't have access. But that was a very manual process, and it's permanent. So if you have stolen my key for a reason, or you infected my machine that has a key built in the AWS CLI, if you see here, AWS CLI configuration, these are programmed long-term credential keys. And it's not dependent on just your operating system. You actually have credentials in clear text inside your file system. So in Linux, you would have it right there. These are example keys and security pairs. If you stole that, you have access to my account. And you have complete access to know what my account profile looks like and long-term credentials to do whatever you want in the CLI. And that's not good. Right? You don't want that to happen. So rather than have that, you could use SSO and grab a token. So if we go back to down here in STS, token. So you can grab an AWS session token based on STS with a combination of an access key and a secret key and token if you're using SSO or some other role-based identity federation management. And we'll showcase this in a second. So back to the reason why we have SSO configured. We're going to pretend SSO is already configured with my other identity providers, and I'm the identity provider back to IAM to a very particular account. I have my Dennis Chow user here, and pretending that he's part of a very particular corporate environment, and I have multi-factor authentication. So I'm going to When we do the authentication piece, I'm gonna have to pick up my phone, use a soft token as part of a best practice. And we look at the profile itself. 3 days ago, last updated, but my token, my session information can be set um, based on those attributes of how long my user session lasts inside here. And you'll see that if you go into your setup as the optional challenge inside your lab. Let's go ahead and grab a PowerShell link. And because I have AWS SSO already set up, I can actually have command line short-lived credential access accordingly. So to do so, I'm going to do AWS SSO login profile. Again, if you set this up in your lab as part of a challenge, you can do the same thing. Rather than me having long-term credentials, and because I've already authenticated already, here we go. We have Dennis SSO. I believe that was my username here. Let's double check on that. Oh, DW Chow SSO. So DW Chow SSO. And only remember it for trusted devices. I'm going to put in my password here. I'm going to sign in, and it's going to ask me for multi-factor authentication. So pardon me while I grab my token, my MFA token here. And we have 197. Don't worry, it changes and rotates. Sign in. And because I got it in the time span, now it's going to say sign in back to my AWS CLI. I have a SAML assertion already in my session provided to me already. And I successfully authenticated. So anything I do with AWS CLI that has SSO login of a particular profile, I can do all kinds of great stuff with that accordingly. If I want to synchronize all of this, I could do all kinds of different things. So if you use AWS STS Git, I forgot what the actual term was, Git session token, AWS STS Git dash, there's no auto tab unfortunately, so Git session token. This is a expiration. So even if you grab all of this and try to say, I have Dennis's AWS admin access. Yeah, I have an access key and a secret access key, but oh no, I need to have a session token that's basically full encoded. On top of that, it's going to expire at this time inside UTC format. And once that expires, I have to get it re-authenticate, get a new session token, and then I can do anything I want. So AWS S3 list buckets, and I'll use the profile SSO. And now I need to use LS. And I have no buckets accordingly. Well, we'll go ahead and change that. Go back to my account. And we're going to create a bucket inside S3. And we'll take advantage of using the CLI wrapper. Notice I'm using the SSO credentials. How do you know you're using the SSO credentials? We'll find out shortly. I'll create a bucket here. Dennis's test bucket tonight. Choose bucket, block all policies. You should always enable encryption whenever possible, but I'm not going to need it right now. Create bucket, and I'm not going to be charged because I'm not going to put anything in that bucket, but I am going to squat that name. So in case someone wants to create the same name, you can't do it. It has to be globally unique. And we'll get LS profile, and boom, just like clockwork, I can list that bucket just like if I was already inside the console using SSO. Now, to verify this, let's look at CloudTrail events. CloudTrail, if I can actually spell. CloudTrail events. Notice that you have to create a trail if you want long-term storage, but you can actually go here to your left, go to event history, and you'll get the last 90 days. Look here, I'm using DW Chow to delete a VPC, which is fine. And this is all anything related to changes. And this could take up to a few minutes to update itself. So we wanted to look up for anything else that has SSO as the user potentially, and all kinds of other great things that go with it. And it's eventually consistent. So you can always have additional information for the last 30 minutes. I have my switch role already, which was done under the guise of DW Chow. And this shows me all kinds of great stuff. Read only equals false. Um, we'll take off that filter. We only equals true, maybe. And here we go. A list of profile permissions, roles, DW Chow, what I am many different times. And I did list buckets right here just now with list buckets using the DW Chow SSO credentials. Click here. It tells me everything, including the access key that I used, the principal, my account number, and everything that happened. Was I MFA authenticated? I don't know why it says false. It was. But that actually means MFA authenticated at the API level. So if I wanted to access S3 and I had a resource policy that says you must be MFA authenticated, that would have failed because I was MFA authenticated to SSO, not at the API S3 resource policy level. I also use AWS CLI, which is a Python wrapper, and my source IP address direct to S3, and I got my call. Now, this is a management-based category. It's doing a list, but notice that it didn't give a particular response. It just said a reference of what was being asked. So all API calls are going to end up in CloudTrail. If you want anything past the 90-day mark, you can certainly download, create a trail, and that will be created as a trail inside your S3 bucket that you have to create, but you will be charged based on the storage. But the charge is minimum, so you can always download CSV files and do different things with it. So just keep that in mind if you want to ever evaluate your other SSO information. So really cool stuff. I hope you learned a lot from this. One thing before we do wrap up and adjourn is that AWS organizations, when we talked about multiple accounts, best practices, not just from a short-term lived credential need instead of a long-term need, because why? If you compromise my credentials, you're not going to get very far within an hour or less. It depends on the program. You can have multiple accounts inside your organization with a single primary account. This is my management account. How do I tell? My account number is right here. My account number is right here as the management account. Cool thing is I can actually enable policies, right? Service control policies, which is right here. You have to actually enable them and say, hey, by default, you can have full access, or you can actually create a policy against saying, and by default, it has a explicit deny saying, hey, I want you to have everything but AWS Athena. And I don't want you to have any access to Athena. We'll create a new statement to say multiple statements here, like conditions and stuff like that, which is kind of nice. We'll remove that. And you can apply that based on tags in the new policy. I won't create the policy. And you can actually apply that policy if you select that attach policy to a particular account or an organizational unit in your account. So you can actually create a hierarchy based on what you need. So if I select SCS Security, which is my secondary account, I can move it into another organizational unit if I create one, if I want to create an organizational unit. All right, and then I can apply the policy to the OU just like we do with user identity groups. So those are some great ways to really keep in mind and help you apply guardrails to your organizational or account level access, regardless of if you make someone an admin in that account or not. Okay, I hope you've learned a lot. We've learned a little bit about IAM users, roles, policies, and trusts. And ultimately, we got to see what federation looks like and what your token looks like and why we use them accordingly. Good luck in your labs, and we'll see you in the next lecture.